Looks like you've made up your mind about becoming an automation business analyst, which is awesome. In the previous Learning Bite, you learned how to determine the automation potential of a process and the factors involved in the assessment. Now, we'll be focusing on the process analysis stage, where we'll learn to analyze the as-is process and define and finalize the to-be process. In the process analysis stage, the business analyst and the solution architect work together to analyze the chosen process in its as-is state and start the process definition document, or the PDD, creation. Using this analysis and based on the complexity of the process, they can determine the extent to which it can be automated. Next, they optimize the overall business flow of the as-is process into what is called the to-be process. At the end of this stage, the to-be process must be created by the business analyst with consultation from the solution architect and agreed upon. The to-be process is what will be implemented. Next, the process definition document is filled in with the as-is and the to-be processes. The PDD is one of the most critical business analysis deliverables because it ensures the transfer of knowledge from the user group to the developers. Once the PDD is completed and approved, the client is tasked with determining the success criteria and creating the user acceptance testing, or the UAT plan. The UAT plan is a document outlining the tests to be performed, as well as the logistics for how end-user testing will occur after development. Clients are responsible for completing the UAT plan, but the business analyst may need to assist them in creation of test cases and scenarios depending on their level of experience. By the end of this stage, the UAT plan must be created and approved. As mentioned earlier, the goal of a business analyst during this stage is to gain a deep understanding of the entire process to document the as-is and the to-be process descriptions. The as-is process description should provide a clear snapshot of exactly how the process operates within the business before the automation implementation. To achieve this, the business analyst will need to gather all the relevant information related to each of the components of the business process: people, technology, and procedures. Standard operating procedures, process maps, organizational charts, user manuals, and all other materials compiled during the previous stages will need to be used. In some instances, some of these documents might not exist, so it would be up to the business analyst to investigate, gather the data, and create them. The to-be process description, on the other hand, aims to highlight the expected design of the business process after automation. The business analyst will thus need to refine the process to its most efficient and effective form by factoring in the potential of automation technology. No less important, at the end of this stage, the business analyst must also ensure a proper handover of the compiled documents to the development team, who will build the automated solution. Let's now analyze the recommended approach towards achieving these goals. There are numerous techniques available for gaining holistic insights into the process, like individual or focus group interviews, discovery workshops, analysis of existing documentation, benchmarking and market analysis, recorded shadowing or direct work observation, surveys, or questionnaires. When it comes to UiPath, we have a variety of products which aid in process discovery, like process mining and assisted task mining. However, to learn more about business processes, business analysts who are new to automation domain typically rely on conducting workshops or meetings with the process owners and the subject matter experts. This allows the business analyst to get a high-level description of the process. At the same time, the subject matter expert, or the SME, can provide meaningful insights on the complexity and challenges posed by the process. The information to be collected during these workouts will also be essential for creating the PDD and can include process metrics such as the scope, the applications involved, the number of FTEs, the transaction volumes, the average handling time of a single item, time dependencies, and the role of each involved stakeholder. All the actions in the process must be described at the keystroke level because the process might not be entirely fit for automation, and we need to clearly delimit what is in scope for automation and what is out of scope. A business analyst must validate this classification continuously while creating the process definition document. The reasons which determine whether an action can be automated or not have to be captured as well. Since the main objective of the business analyst during this stage is to attain information to be included in the documentation, proper planning is mandatory to ensure success. Gathering and structuring data is a complex endeavor, especially if there are numerous stakeholders involved. Consequently, an iterative approach is recommended when creating the documentation. The business analyst can thus capture the process-related information at a granular level and help the implementation team adapt to the changes. Let's see what the suggested stages are for documenting the process. There is requirements gathering, where basic process information is collected and documented. Then the next step is creating high-level process maps, complemented by process descriptions. To ensure that the information is accurate, validation from the process owner is needed afterwards. For the documentation to be complete, the business analyst has to include more scenarios and business rules, which in turn need to be validated by the process owner. If those steps are completed, a detailed process map with an end-to-end description can be created. The next step is to describe the to-be process flow and the solution. In this step, the business analysts also need to mention the activities or process steps that are in scope and out of scope for the automation. The process definition document can then be completed and signed off. Now that we have a clear high-level view of the steps involved in the documentation process, let's go over some specific details. As already mentioned, the first step is gathering all the required process information and data. The process metrics can be captured with the help of existing workflow or business process management tools. Time and motion studies provided by the operations team might also turn out to be extremely useful. The purpose is to find out the transaction volumes, the average handle time, and the total FTE effort. Next, the process-related information needs to be collected. The first piece of information consists of the open and close times, as well as the time dependencies involved in the process. That is relevant if certain activities can only be performed within a specific time frame, for the robots to be configured accordingly. Another piece of information is any expected increase in transaction volume to anticipate if the robots need to be scaled up. A list of all the involved stakeholders and their roles must be provided as well. The process input, the resulting output, and their type are also mandatory. Let's move on to the information related to the infrastructure requirements, which includes the availability of a test environment, as well as the hardware and software requirements of the UiPath components. Both pieces of information must be captured by the business analyst in the documentation. Every process involves the use of many applications with different underlying technologies. To compile a comprehensive documentation, the business analyst needs to understand all the applications that are part of the process, how they work, and whether different application instances are used, as in the case of mainframe applications. So applications that support the process should be listed in the PDD along with their supported versions. Finally, the use of virtual environments is crucial in determining whether the client is a thin or a thick one. Thin clients are those that require the automation of a virtual desktop, or a remote one, while thick clients only use desktop applications. That concludes the list of requirements that must be gathered to ensure that the process-related documentation is complete. We have already mentioned the preparation of a high-level process map as part of an iterative approach towards process documentation. Let's now look at the data that needs to be included for each step in the process. We will exemplify this by referring to our order-to-cash use case from the first lesson of the course. The business analyst first needs to mention the name of the step, for which we recommend using a short description of the action taken, whether it's manual, automated, or semi-automated, the applications used, and the average handling time. A series of cross-functional flowcharts can be used to describe business process maps. Each flowchart is of a certain level, between 0 to 4, depending upon the amount of details it has. A level 0 flowchart contains the least amount of details, whereas a level 4 flowchart is the most detailed. At this level, every task, however minor, is represented. So the next step in documenting the process description is creating a level 4 process map, including detailed information on the process steps, the valid variants of the process, and the team involved in each of the activities of the as-is process. A similar map for the to-be process is then created by the business analyst in collaboration with the solution architect. The L4 process maps must contain all the possible scenarios and variations of the process to ensure that the automation can be carried out smoothly. There are certain tools that can be used to improve the process visualization, including the Business Process Modeling Notation, or the BPMN framework, the ARIS approach, as well as Microsoft Visio or Lucidchart. Let's move on to the information related to the process input and output. We will start with the input, which needs to be identified both at the process level as well as at a more granular level, including the dependencies of other sub-processes, if any. The business analyst needs to document the input source, which can be an application, a file, a desktop screen, an email, a scanned invoice, and so forth. The input structure, which can be provided using templates, the fields that contain the input, and finally, the input location, or where the application or file containing the input can be found. In the to-be process documentation, the business analyst needs to make sure that every input and source is thoroughly analyzed and standardized whenever that's possible. Inputs can be drawn from pre-existent files included in activities, for instance, a report that triggers some actions, or specifically created for the automation project that includes data posted for the sole purpose of being used by the robot. Likewise, business analysts need to identify whether the output already exists or the robots must generate it. They also need to mention the output type and structure, the content, what triggers it, and the location to which it has to be saved. The output can be represented by a file, a report, an email, a new record in the system, etc. Lastly, it's important to remember that there can be multiple outputs for a single process. Let's continue by discussing the different forms of documentation and tools that the business analysts can use to capture the details of the process. Depending on the situation and the specific requirements of each process, we can use a combination of keystroke documents, process recordings, and a business logic translation table to create the process description. Please keep in mind that these documents need to be up to date, otherwise using them will only result in creating confusion and will fail to bring any added value. Now, let's go over some specific details. All the activities that are part of the process and all the actions performed by the SMEs on the application layer must be documented at the keystroke level and accompanied by illustrative screenshots, which can be created using tools such as the Microsoft Screen Recorder or the Assisted Task Mining. However, the best way of capturing complex business rules is by creating video recordings of all the process activities individually and adding the appropriate explanatory voiceovers. The videos can then be indexed and used as references in the as-is process description to smooth out the entire process. In what concerns the business logic translation table, this is an optional piece of documentation which does not apply to all processes. It typically contains mappings between certain situations and the actions that need to be taken. For example, think about a support center having a mapping between the types of tickets they receive and the response templates used to reply to customers. Business analysts can either use an existing business logic translation table that the customer may have, or create a new one in a separate file. If any change in the rules ensues, the table can be updated directly with a low impact on the code. Business analysts can also index the business rules and use them as references in the as-is process description. Alright, so far, we've focused mostly on the activities that can be automated. But let's also talk about those that are out of the scope for automation, because they need to be included in the documentation as well. In this regard, let's first understand why certain activities are unfit for automation. Let's look at some examples of activities that cannot be automated to clarify this matter. Firstly, there are processes with clear compliance requirements stating that some of the activities must remain under the control of the team members. Obviously, those activities are not considered to be in the scope for automation. Secondly, there are activities that involve the use of applications which are liable to quick changes, like in the next 3 to 6 months. We do not automate these ones together. However, it's a good practice to maintain a log of such applications or activities. This backlog can be referred to later, and a decision can be made around which activities to automate or ignore. Other non-automatable activities are the ones involving input that is not standardized or scanned images of poor quality, and the ones where human expertise is mandatory because they are very complex. Lastly, if the automation effort exceeds the benefits, or the percentage of the processed transactions is lower after automation, the activity is out of scope. Now that we have seen some examples, let's return to the documentation. The impact of the activities that cannot be automated has to be analyzed according to certain criteria, whether they change the order in which the rest of the steps are performed, whether they require the robot to be restarted, whether the robot has to wait for the non-automatable activities to be performed, and whether the robot uses the output of the non-automatable activities. It is a must to document all this information. Let's proceed to discuss exception handling. Exceptions appear in a business process when something unexpected happens during the process execution. When documenting the process and designing the as-is high-level process map, the business analyst will focus first on the normative or desirable behavior, also called the happy path, showing what is supposed to happen when everything goes smoothly. After having the big steps defined, the next action is to think about what might go wrong where the business process is executed. What can happen if one of the steps is not performed in the expected way? Most exceptions are anticipated and documented in the design phase. However, it's almost impossible to cover them all until you encounter them during runtime. Keep in mind that a process documentation that describes only the happy path is considered incomplete, so it's important to keep track of both business exceptions and technical exceptions. During the process deep dive sessions, the business analyst must make sure to uncover all possible scenarios when something might not go as planned. Also, it's essential to include in the documentation the ways in which the automation can handle each exception. Business exceptions are caused by the business logic implemented in the robot. For instance, mandatory information might be incomplete, missing, or unidentifiable in a form or document, or email attachments that act as process inputs might be unavailable. In both cases, an exception is thrown. Application or system exceptions occur when the applications used in the process are faulty. For example, when they stop responding or the robot fails to log into a system. Exceptions must be handled appropriately. For example, by sending an email to a human operator or by other means that are in accordance with the business rules or situation. The exceptions encountered can be known and unknown. The known exceptions are those that have been encountered before and for which a workaround is available. The logic of exception handling differs from one known error to another. The unknown exceptions consist of unpredictable situations which have never been encountered before and are usually caused by external factors. When these exceptions occur, an authorized person must be notified to evaluate the situation. The exception handling logic is the same in the case of all unknown exceptions. Also, it's important to make the difference between exception and variant. A variant is considered a path that uses the same input and delivers the same measurable outcome as the desired path, but in a different way, whereas an exception usually may require special conditions and permission to be included in the process. So far in the process analysis stage, we have learned how to analyze and document the as-is process and how to define and finalize the to-be process. Next, we will learn about the process definition document in detail.